So here we have one of the stereotypical type of word problems. This boat is going down the river, which means that the speed of the river or the current is going to speed it up as it goes down the river. When it returns back up the river, then the current is going to be slowing it down. So I'm just going to use the letter R as the speed of the river, or in other words, the current. The speed of the current is going to be the letter R. And then the boat, just by itself, like if it was on a completely flat lake, how fast is the boat propelling itself? So I'm going to use the letter B for the speed of the boat. And then, of course, we use the good old-fashioned distance equals rate times time formula. And because there's information about going upstream and downstream, I like to make a little box like this. And one row is going to be the first thing that I said when it was going down the stream, and then when it goes up the stream. And then we'll just cut this off as this will be D, the middle will be R, and then T. Okay, so it says that it is going 20 miles. So I know that each time it's going to be 20 miles. So distance equals 20 miles when it goes down the river. And it's going to return, so it'll have to go 20 miles back up the river. And also, we've got this time information. It takes 2 hours for going down the river. So this time is 2 hours. And then 3 hours for the return trip going up the river. So it's going to take longer because the river is going against the current as it returns up the river. Next up, what about the rate? So what goes here and what goes here? Well, since the boat itself has a speed, and when it's going down the river, it actually gets sped up by the current. So right here is going to be the boat itself plus the river's current. And then as it returns, it's going to be B minus R. Now, of course, this is an ideal situation if you had a boat that perhaps had a very efficient hull. There might be some other things to consider, but this is not physics class, so we're just going to do the math. So using the distance equals rate times time, then the top equation, or the top row, is going to become 20, the distance equals the rate, B plus R, times 2. And the bottom one is going to become 20 equals B minus R times 3. And now we have two equations, and since they both are equal to 20, that means I can just set them equal to each other, or I can set it up as two equations. So the thing is, if I set them equal to each other, then I only have one equation and two variables. So I really do need to have two equations and two variables. So in this case, I'm just going to go ahead and distribute the 2 for the first one. So the top equation will become 20 equals 2b plus 2r. And for the bottom one, distribute the 3. So this bottom equation will become 20 equals 3 times b minus 3 times r. And then what I think I want to do is use the elimination method. So if I can get this to become a positive 6, and I can get this to become a negative 6, then when I add the equations together, they will cancel out. So for that, I need an orange pen. So to make this one become a 6, I'll need to multiply by 3. So in other words, I need to multiply the top equation by 3, and to get this one to become a 6, I'll need to multiply by 2. So then I need to multiply, oops, sorry about that, stay there. I'll need to multiply the bottom equation by 2. And then back to the black pen. So this will be 60. Distributing, this is going to be 6b plus 6r. And for the bottom equation, distribute the 2, so that's going to be 40 equals, that's going to be 6b, and then minus 6r. Now that I've done that, add the equations together. So on the left side, 60 plus 40 is 100. These with the r are going to cancel, and then there's going to be 12b. So to solve for b, just divide both sides by 12. And then how much is 100 divided by 12? So that's not really worth switching the screen over to the calculator. I'll just do that on the side real quick. That equals an 8.33. So by itself, the boat would be going 8.33 miles per hour. Now let me see, does that answer the question? Find the speed of the river's current. So I still need to solve for r. Okay, so I can just grab one of these equations. So I'm just going to grab this one as I clean it up. So just grab one of these equations and bring it down here. There we go. And now just substitute that the b is going to be an 8.33. So we have 20 equals 2 times 8.333 plus 2r. And then, you know what I could do to simplify this? I could divide all those numbers by 2. It's not the only way to do the problem, but I just noticed that they all have a 2, so then I could divide by 2. And then we've got 10 equals, and these 2's will cancel, and these 2's will cancel, so that leaves 8.33. And then since the 2 cancels, there's just an r. And one last step is subtract the 8.333. I'm sure the 3's go on forever. So anyway, when you subtract, that's going to be 10 minus 8.333, and that is a 1 2/3, or 1.667. So if you want to look fancy, you could write that as a fraction, 1 2/3 miles per hour. So that's how fast the current is going.